So in the previous classes, in your junior classes, you have already heard about anything dedicated to sound, such as sound is basically a voice, or in the other words, basically music pronounced from the mouth, listen from the ear, and these are the very easiest topics in your junior classes. But basically, there are the types of sounds such as the echo and what does mean by the ultrasound, and also what is the wave of the sound. So basically, now in the O levels for IGCSE and for GCE O levels, describing the sound is very essential. As one of the chapter is that sound waves are produced by vibrating sources. It means that you must know that how the sound waves are being produced. When a sound wave comes into contact with a solid, those vibrations can be transferred to the solid. It means that when a solid wave comes into contact with a solid, those vibrations can be transferred to the solid. Means now the vibrations can be transferred. Through this, the sound is created. The sound waves is generated. For example, sound waves can cause a drinking glass to vibrate. All right, and if the glass vibrates too much, the movement causes the glass to shatter. As you can see, here is a longitudinal wave. Here is mentioned longitudinal wave. Otherwise, I was been asking from you that which type of wave is this, because in my previous live streaming session, I've already taught you about the difference between the longitudinal and the transverse wave. So unfortunately, it is mentioned here. Otherwise, I was been asking from you that which type of wave is this. So you can see that if it was not written either, so you can identify by the compression and rarefaction. So here, the red arrow is showing the direction of vibration, while the blue arrow is showing the direction of energy transfer. So through this, the direction of vibration is from the left to the right and from the right to the left. It means that it is having a proper oscillation. All right. Sound waves are longitudinal. Said now forget the transverse wave in the sound. Now do not forget it for the paper, but forget it for the sound. And for the sound waves are longitudinal. The molecules vibrate in the same direction as the energy transfer. Alright. Sound waves require a medium to travel through what matter. This means that if there are no molecules, such as in a vacuum, then the sound can't travel through it. That's why it is very typical for you to listen the voices from the space, from in the solar system from the space. It is typical for you guys to just listen the sound because there is entire vacuum. Uh, there's no molecules basically. All right, so just give me 2 minutes. All right. So now understanding the compression and rarefaction as extended means it is important. Okay. Longitudinal waves consist of compression and rarefaction. What does it mean? So a compression is a region of higher density. For example, a place where the molecules are bunched together. And a rarefaction is a region of lower density. For example, the place where the molecules are spread out. In the other words, you know about the compression, that to compress, we have already understand this in the properties of solid, liquid and gas. Yes, that what is the property of the solid, that it is incompressible. It means that it's just not compressible, it cannot be compressed. In the rarefaction, you can also took the another words known as extension, means to spread out. So this is what the basic definition. The rarefaction is basically the another word of for the extension. As the examiner used this word in the paper, so you must understand about it that this means extension. Here you can see the diagram is showing clearly that what is the compression and what is the rarefaction, and I hope so that after seeing this image, it would be easier for you to determine whether it is compression or rarefaction. Now I'm making you understand about it because in MCQs it appears a lot that what is compression and which part is rarefaction. There has been labeled as ABCD. Sound is a longitudinal wave consisting of compressed rarefaction. These are areas where the pressure of air varies with the wave. Alright. These compressions and rarefaction causes changes in pressure which vary in time with the wave. Therefore, sound is a type of pressure wave. It changes in the pressure. Obviously, okay. When the waves hit a solid, the variations in pressure causes the surface of the solid to vibrate in sync with the sound wave. Alright, so it means that there is again the vibration for which the vibration in the pressure causes the surface of the solid to vibrate. For this reason, that there is a pressure in the surface of solid, um, the particles of the solid vibrate because of the variation in pressure. Alright. So this is the speed of sound in air. Sound waves travel at a speed of about 340 meter per second in air at room temperature. The higher the temperature, the greater the speed of sound. It means that the temperature is directly proportional to speed of sound. The speed of sound in air varies from 330 to 350 meter per second. Speed of sound in materials. So basically, this is not essential for you to memorize that what is the sound, what is the speed of the sound of gas, liquid, and solid, as it doesn't appear in the paper. But you must understand that sound travels at different mediums. You must understand that the sound travels faster in solid and slowest in gases. It means that the air, we took the example in the air. If you are in a room and the room is packed, so now you can say that what if you'll be shouting, so there is a lot of noise because of the reason that the sound is traveling faster. All right, and for which if we speak more louder, so sometimes the glasses breaks because of the reason that why does it broke? Because louder voice, because the louder sound and the speed of sound hit the solid, so that's why the solids broke. Sorry, the glasses broke. Glass is the example of solid. And what about the gases, such as you are standing in the air, you are standing on a mountain for suppose, and you're shouting in the air, so there must be uh, very less voice skimming, and the speed of the sound is very slow, for which you can it is very difficult for another person to listen your voice when you are shouting in the air. All right, so the table shows the typical speeds of sound. If you are required to memorize, if you want to, so you can, but it is not essential. Measuring the speed of sound. Okay, there are several experiments that can be carried out to determine the speed of sound. Three methods are described below. The apparatus for each experiment is given in bold. Okay, method number one, measuring sound between 2 points. So it is that how you can measure the sound between 2 points. So it is the A and B, and 100 meter or more is having the distance. The distance is described as 100 meter or more distance, and a person is clapping and the girl is having a stopwatch. So this how you can determine. Taking another example which must be better for you, first explanation. Two people stand a distance of around 100 apart. Okay, the distance between them is measured using a trundle wheel. Okay. One person has two wooden blocks which they band together about their head, as you can see here. The second person has a stopwatch which they start when they see the first person banging the block together and stopping when they hear the sound. This is then repeated several times and an average value is taken for the time. The speed of sound can then be calculated using the equation as the speed of sound is equal to traveled by sound upon time taken. Is this formula very difficult for you to memorize? So can you just take the example as speed is equal to distance upon time? So yeah, I've already tell you in the kinematics. All right, so this is the second example. Uh, the using okay, so it is using echoes. So here's the second example using echo. So what is basically the echo? So we'll discuss this in the video later, but this is the hint that the echo is the repeated sound. So what is that? We'll be discussing it. Okay, so clap, 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 and the person is clapping, and there's a wall, and 50-meter or more distance is described. So now read this: speed of sound using echoes. A person stands about 50 meters away from a wall or cliff using a trundle wheel to measure this distance. The person claps two wooden blocks together and listens for the echo. A second person has a stopwatch and starts timing when they hear one of the claps and stop timing when they hear the echo. Echo means a second clap. The process is then repeated 20 times and an average time is calculated. The distance traveled by the sound between each clap and echo will be 2 multiplied by 50. Obviously, why we are multiplying the 2 by 50? Because echo means the repeated sound. Number one, we are having the sound, and another, the reflected sound is called echo. Okay, so the reflected sound is echo. It means that there must be two sounds. So that's why the 50 is multiplied by 2. The speed of the speed of sound can be calculated from this distance and the time using the equation, such as speed of sound is equals to 2 multiplied by distance to the wall upon time taken. It means that now there is an addition, such as speed is equal to time taken. Remember, for the echo, it is essential for you to multiply the distance by 2, because of the reason that there is a reflected sound. One, the sound was being going there, and another sound came back. So this having the two time, for which we multiply distance by 2. What is mean by pitch and loudness? This is essential now. The frequency of a sound wave is related to its pitch. Understand the relationship? Sounds with a high pitch have a high frequency or short wavelength. When the frequency is high, so there must be short wavelength. Sounds with a low pitch have the low frequency. Means the sound with the high pitch means the pitch is directly proportional to frequency. All right. The amplitude of a sound wave is related to its volume. What does mean by the frequency and amplitude? We have already discussed in the chapter number wave. Okay. Sounds with a large amplitude have a high volume, and sound with a small amplitude have a low volume. It means that amplitude is directly proportional to volume. When there is low frequency, the pitch is low, and when there is high frequency, there must be high pitch. Understand? So remember, in the exam, they'll be giving you the amplitude and the frequency, and you must determine if this amplitude is small, so the pitch is high and the volume is low. What does mean by echoes? Sound waves reflect off. Now here is clearly written that it reflects off hard surfaces. The reflection of sound is called an echo. This is the simple definition. Echo sounding can be used to measure depth or to detect objects underwater. A sound wave can be transmitted from the surface of the water. The sound wave is reflected of the ocean. Sound wave to return is used to calculate the depth of the water. The distance the wave travels is twice the depth of the ocean. Alright, it's twice the depth of the ocean. Why it's twice? Where the word twice or the double comes, or by multiplying by 2, so remember that it's talking about the echo. As we have already know that the reflection of sound is called echo. Means one sound goes there, it reflects back and came back here. So it's not two times. The distance the wave travel is twice the depth, okay? This is the distance to the ocean floor plus the distance for the wave to return. Ultrasound. Father or any else goes for the ultrasound, and I hope so that there is no patient that you have already observed many times that your family members or in the hospitals there are many patients who came for the ultrasound. It means that it is related to the magical. Yes, humans can hear sounds between about 20 hertz and 20,000 hertz in frequency, although this range decreases with age. Okay, so this is the range of frequency. What does Hz means? It is the SI unit of frequency. Okay, uh, this might be appear as an MCQ or can be come in your P2 that express that what is the minimum to the maximum frequency a human hair can heard. Okay, so here's a low frequency and pitch. The diagram is showing you that from the 2 hertz to 200,000 hertz. Okay, from the range of human hearing is 20 to 20,000, and above it is called ultrasound. So what is ultrasound? High frequency and pitch. Now you also focus on the blue wave. What does the blue wave is showing? It is showing a high amplitude and more pitch. That's why the high volume and the high, what does mean by high volume and the high sound, and there's a low frequency and medicine. In can be used to construct images of a fetus in the womb, to generate 2D images of organ and other internal structures, as long as they are not surrounded by bone. Transducer that produces and detects a beam of ultrasound waves into the body. It is used. What does it used for? To construct the images in the mother's stomach. Oh, sorry, in the mother's womb, and to generate the 2D images of organs and the other internal organ structures, and also have the medical treatment for removing kidney stones. So these are the examples. Can be appear in your paper exactly, and most in your P1 or P2. All right. The ultrasound waves are deflected reflected back to the transducer by boundaries between tissues in the path of the beam. For example, the boundary between fluid and soft tissue or tissue and bone. When these echoes hit the transducer, of each echoes reaches the ultrasound, an unborn baby can be seen from the image. Unlike many other medical imaging techniques, ultrasound is non-invasive and is believed to be harmless. Obviously, when a mother is pregnant, so we just use the ultrasound machines uh, used for ultrasound, so that we can see the unborn baby. But the rays must be in your mind. There's a question that the rays must be harmful for the baby. So no, there it is written clearly that it is non-invasive and is believed to be harmless. Obviously, for which a longer period of time there is an ultrasound. In number one, a pulse of ultrasound is emitted by transducer. Now just understand the procedure. As you can see, this is the stomach of the mother, and at the besides there is the screen where you can see the baby clearly. Okay, a pulse of ultrasound is emitted by transducer. In the second step, the pulse reflects at boundaries in the body. Now see how it is reflecting the red rays, showing that it is going inside. The reflected pulse is detected by transducer is blue colored. Now you can see it is reflected by the boundaries in the body towards back to the transducer. The signal is processed to be used for medical diagnosis. And this is how the ultrasound can be used. Simply about the ultrasound. So this is how the transducer work, and this is how the ultrasound is used. Remember one more thing at the ultrasound, what we learn is that this is the voice more than 20,000 hertz. The frequency must be 20 frequency from the screen. So till that it's here. If there must be any questions, so just comment me below. Until that, it's almost done. So our chapter is completed. One thing is left, which is about the to subscribe, and do not click the bell icon. Do not forget to click the bell icon. Okay, so till that.